The critical path method is frequently used in the development and control of projects. Its principal objective is to determine the length of a project, understanding it as a sequence of activities related between them, where each one of the activities have a certain duration. Step 1. Define the project and all his activities. Step 2. Establish a relationship between the activities, tell which should begin first, and which later. Step 3. Draw a diagram connecting the different activities, in base of their relationship. Step 4. Define the price and length of each activity. Step 5. Identify the longest path of the project, being this the one that is toning, to determine the length of the project critical path. Step 6. Use the diagram as help to plan, supervise and control the project. To represent the activities we frequently use the next notation, where A is the activity, IC is the nearest beginning, it means, the soonest the activity can start. TC is the nearest end, it means, the soonest the activity can finish. IL is the further beginning, it means, the latest the activity can start, without delaying the end of the project. TL is the further end, it means, the latest the activity can finish, without delaying the end of the project. And S is the clearance. We also have to consider the clearance for each activity, that consists in the maximum time an activity can be delayed. Without delaying the end of the project, we can get the clearance with the next formula. L minus IC is equal to TL minus TC. Example: in the next chart, we have the necessary activities for completing a project. We can't change the length of each activity, and we are asked to determine the total length of the project by using the CPM. First, the diagram is constructed by identifying each activity in a circle with their respective name, and in parentheses the estimated time. The arrows between activities indicate relations. For example, activity F can only begin after completion of activities D and E. Then we identify the indicators IC and TC for each activity. For example, the nearest beginning for activity C is 8. This because C only, it can begin once A and B are finished, being B the most delayed, and finishes in 8, and the nearest term is 20 provided that the activity C delays 12 weeks. Later IL and TL are obtained for every activity. With this information, the calculation of the clearance of every activity is simple. To obtain IL and TL of every activity, we move from the end up to the beginning. In this case, the activity that ends later is H49 sim, and therefore we ask ourselves when is later that it could end H without delaying the project TL. This clearly is 49. Therefore, if later that H can ends is 49, the latest H can begin is 41 given a clearance of 8. Then the clearance of H is 0. In the end we have a critical path with a total duration of 49.